Hi friends, I am Adarsha. I am studying Bachelor of Engineering, Sri Venkateswara College of Engineering. The branch is Electronics Communication and Engineering. Today we know about the Norton's theorem and problem on that theorem in the subject network analysis. Norton's theorem statement. It states that the linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source IN in parallel with a resistor RN, where IN is the short circuit current through the terminals and RN is the input or equivalent resistance at the terminals when the independent sources are turned off. It is the statement. We can see the diagrams as per the statement says that. Let us come to the proof. Consider a network with R1, R2, R3 resistors and one voltage source V and load resistance RL. The current flow through the load resistance is IL. Using current division rule, we can find IL. IL is equal to R2 divided by R2 plus R3 plus R1 into I. We don't know I. To find I, rewrite the circuit with one resistance and another resistance parallel with R3 plus RL and one voltage source, that is equal to R2 into R3 plus RL divided by R2 plus R3 plus RL, that is equal to R2 R3 plus R2 RL divided by R2 plus R3 plus RL. From the above network, I is equal to V divided by R1 plus R2 R3 plus R2 RL divided by R2 plus R3 plus RL. I is equal to V divided by R2 R1 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL divided by R2 plus R3 plus RL. This is the I. We substitute this I into the IL. IL is equal to R2 divided by R2 plus R3 plus RL into V divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL divided by R2 plus R3 plus RL. R2 plus R3 plus RL, this one will cancel each other. There IL is equal to V R2 divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL. This is the Norton's equation. In the step 1, to find IN, remove the load resistance and short circuit terminals A and B to find the current. By using the current division rule, IN is equal to R2 divided by R2 plus R3 into I. To find I is equal to V divided by R1 plus R2 R3 divided by R2 plus R3, that is equal to V divided by R1 R2 plus R1 R3 plus R2 R3 divided by R2 plus R3. Substitute I in the IN. IN is equal to R2 divided by R2 plus R3 into V divided by R1 R2 plus R1 R3 plus R2 R3 divided by R2 plus R3. Therefore IN is equal to V R2 divided by R1 R2 plus R1 R3 plus R2 R3. The next step is to find the Rn. Make all the sources in the network is 0 and find a total resistance of a network in the terminals A and B. We can rewrite as a circuit into the R1, R2, R3. Therefore, equivalent resistance Rn is equal to R1, R2 divided by R1 plus R2 plus R3. R1, R2 plus R1, R3 plus R2, R3 divided by R1 plus R2. In the step 3, write Norton's equivalent and connected load resistance across the AB. In the figure, we can see the IN is parallel with the RN and connected RL between the terminals A and B. Therefore, IL is equal to RN divided by RN plus RL into IN. We already find Rn and In. Substitute that values in this equation. IL is equal to R1 R2 plus R1 R3 plus R2 R3 divided by R1 plus R2 whole divided by R1 R2 plus R1 R3 plus R2 R3 divided by R1 plus R2 plus RL. into V R2 divided by R1 R2 plus R1 R3 plus R2 R3. In that denominator to cancels each other, and VR2 divided by that denominator will cancel with the numerator the another side. The remaining IL is equal to VR2 divided by R1 R2 plus R1 R3 plus R2 R3 plus RL plus R2 RL. From above equation and in this equation we can prove that Norton's theorem. Let us come to the problem on that Norton's equivalent circuit. This is the problem: 10 volt source and 4 ohm on resistance, 4 amps on current and 2 amps on resistance, 5 volt on voltage source, and for 10 ohms on the resistor and terminals A and B. Using source transformation, we can convert 4 amp and 2 ohm resistor into the voltage source, 8 volt and 2 ohm. In this diagram, to find IN, we short circuit the terminals A and B to find IN. Then apply the KVL into the two loops I1 and I2. When apply the loop 1, minus 10 plus 4 I1 plus 2 into I1 minus I2 plus 8 is equal to 0. 6 I1 minus 2 I2 is equal to 2. The second loop, minus 8 plus 2 into I2 minus I1 plus 5 plus 10 I2 is equal to 0. Minus 2 I1 plus 12 I2 is equal to 3. We can write these two equations into the matrix form. We can directly calculate the matrix in the scientific calci. Then I1 is equal to 0.44 amps, I2 is equal to 0.32 amps. Therefore IN is equal to I2, because I2 flows through the IN, so only IN is equal to 0.32 amps. Let us come to the next to find RN. We remove the sources and to calculate the resistance equivalent, Rn is equal to 4 into 2 divided by 4 plus 2 plus 10. That Rn is equal to 11.33 ohms. To rewrite these all values into the Norton's equivalent circuit, current IN 0.32 amps and Rn 11.3 ohms. Resistance Rn right parallel with the current. Thank you, friends.